As the American fleet closed in on the Strait of Hormuz with the mission of reopening it and restoring the flow of oil tankers, the U.S. Navy encountered a serious challenge. Iranian forces had seeded the strait with underwater mines, effectively shutting down maritime traffic. Clearing them would become one of the most dangerous stages of the entire operation, demanding extreme precision, patience, and continuous defense against potential Iranian air and missile strikes at the same time. These were not the crude floating mines of earlier wars. Modern naval mines are far more sophisticated. Some rest on the seabed, others are suspended at calculated depths below the surface, completely invisible to the naked eye. They rely on multiple sensor systems, magnetic, acoustic, and pressure-based, to detect targets. A magnetic sensor identifies the metal mass of a ship by detecting distortions in the Earth's magnetic field. An acoustic sensor listens for the unique sound profile of engines and propellers. A pressure sensor registers the change in water pressure caused by a large vessel moving overhead. The most advanced mines combine all three systems, requiring specific conditions to be met before triggering. That means a ship can be destroyed without ever making physical contact with the device beneath it. While unmanned underwater vehicles scanned large sections of the area, certain situations required a human touch. Below deck, Navy explosive ordnance disposal divers prepared for deployment. They suited up methodically, wetsuits secured, breathing systems checked, dive computers calibrated, underwater lights tested, communication gear verified, and tools locked in place. Once ready, they boarded rigid hull inflatable boats and moved out toward coordinates identified by the scanning teams. As the divers advanced toward their target zone, the rest of the fleet maintained maximum defensive readiness. Sailors remained stationed behind heavy machine guns, eyes fixed on both sky and sea. Lookouts rotated continuously with binoculars, scanning the horizon without pause. The threat of an Iranian drone or missile strike, while the fleet was slowed and focused on mine clearance, was constant and very real. The fleet reduced speed to the absolute minimum. Moving too fast increased the risk of striking an undetected mine. Every vessel in formation slowed to a crawl. Sonar systems and mine detection scanners operated at full capacity, sweeping the waters ahead and beneath each hull. Cruisers and submarines were placed on full combat alert. Air defense systems remained active, tracking for incoming threats, whether Iranian Shahed drones or ballistic missiles that could be launched at any moment, while the fleet remained exposed in the narrow strait. From the carrier, helicopters launched and began systematic patrol patterns ahead of the fleet. Door gunners sat ready behind mounted weapons, scanning for threats both in the sky and across the water's surface. Some helicopters deployed specialized mine detection gear, towing sonar sleds through the water on extended cables. These systems scanned the seabed in real time, feeding data directly back to command. Sector by sector, the crews swept the path the fleet would follow. The divers reached their designated location and entered the water. They descended carefully along the coordinates provided by sonar. Visibility was limited. Moving slowly along the seabed, they used their lights to search through coral formations. They located the mine, lodged deep within the reef, partially buried in a position that made it inaccessible to unmanned systems. The divers conducted a close visual inspection, identified the type of mine, assessed its condition, and relayed the information back to the ship through underwater communications. The call was made. Manual disarmament was too dangerous. The mine's position within the reef made direct handling a high-risk move. Instead, the divers marked the site and began their ascent. Once on the surface, they cleared the area and returned to their inflatable boat, creating safe distance from the target. Back on the ship, the crew deployed a mine disposal vehicle, a remotely operated submersible specifically designed for neutralizing underwater threats. The vehicle was lowered into the water and guided remotely by an operator monitoring a live video feed. It descended toward the mine, maneuvered carefully into position, and placed an explosive charge beside it. The operator confirmed proper placement. The vehicle then backed away to a safe distance. Inside the operations room, everything was visible in real time. The commanding officer, the EOD team leader, and sonar operators all watched the same feed, tracking the mine, the vehicle, and the charge placement with complete clarity and control. Moments later, the charge detonated. A muted underwater blast sent a plume of water and debris to the surface. The mine was gone. Sonar confirmed it. The contact had disappeared. That section of the route was now clear. Meanwhile, below deck, ammunition crews moved quickly. Crates of belted rounds were brought up for the deck-mounted heavy machine guns. The belts were unpacked, inspected, and carried into position. They were loaded into the weapons and locked in place. Gunners charged their systems and fired short bursts over open water, confirming full functionality. These machine guns served a critical dual role. They could engage aerial threats like drones, and they could also be used to safely detonate any floating mines spotted on the surface from a controlled distance. Step by step, the fleet carved a path forward through one of the most dangerous waterways on Earth.